Hello there, my name's Vince from My Mate Vince, and another Advent potential fix. In this one here, we've got some Einhell hedge cutters or hedge trimmers. Run off an 18-volt battery. This battery is a known working battery, and yet when I plug it in here, nothing happens. Has definitely had use, because when I take off the guard here, I can see that it's had use, but I don't think it's had a serious amount in use. But there is definitely oil marks and sort of where the paint's come off there. But without the cover on there, you can see nothing's happening. I'm holding down this catch and this one here, and it's not doing anything. So we have to find out why. It says here that it's got metal gears, but I can't even hear the motor working, and also diamond grinded laser cut knife. So yeah, I don't think they're overly expensive, but it might be interesting on the inside to find out what's gone wrong with it. I'm going to say it's something to do with one of the switches. You can have a think about what it is. Let's get over to the mat and let's see what's wrong with it. Right, this might not be the easiest thing to film, but I will keep the safety guard on it for the moment. Now I've got a load of screws to undo around here. They all look like crosshead. That's not going to read. Might as well take this off. I don't know why that was left on. Maybe that was put on again just to when it was sent back, or maybe make it easier to sell. My prediction is that this is going to be really easy to diagnose. Now that I've said that, it's going to be a nightmare. It might not be fixable, as in it might be if it's like in a switch and it's all burnt out or something, I might not be able to fix it, but I think it's going to be easy to diagnose. I can't see it being too complicated in here. Right, I'm going to also have to take this off, aren't I? So, I'm curious as to where the wires are fed through. Oh, we've got screws here as well. Okay. Let me start with the small ones. And we've got screws here. You know what? I might not have to take apart the body because everything might be done from here if it's a fault on this switch. Wow. That is a long one. Okay, is that gonna... There's wires going down there into there. But I can take off this side. Alright, well let's leave that as it is for the moment. Well, that's nice, we've got some hedge cuttings in here. Well, do you know what? Let's... oh, and we got a nut the other side off that there. The long bolt. Let's undo this here. And let's see, in case it is this quickie switch at fault. Right, here we go. I'm going to keep that upright. It's just a couple of springs that makes it spring out. So here we have one of the switches. So let's get our meter on continuity and see if this switch is working. So if it beeps, it means it's working. What's that about? Why is that on all the time? And in fact, why have we got 3 wires going to it? Let's try to unclip it. Okay. Not quite sure what's going on yet. So let's just go between here and here. Go between here and here. Let's go between here and here. Okay, it's going off all the time, but it did seem to be jumping on the ohms. So let's go to a normal ohms test and let's see what that's reading. So between here and here.
So we have a full short, yet the same as my leads. Now what happens when we press the button? Nothing. So nothing on those two. Right, now let's go to these ones. Again, full short. But can you see? It does jump. Do you know what? It's going to be reading. It's going to. I'm reading the motor or something, aren't I? If you have a look here, it's labelled up what's what. Can you see here? This is the common. No connect and no. Would that be on? No, it's faced that way around. Okay. So we should have a connection between here and here when we do this. I'm going to pop these out. I'm going to take a picture. I'm going to pop them out, and then we know 100% if the switch is okay. Because right now I think I'm measuring, for example, the motor. Right, these are going to have those little tabs in them that you have to press down. In fact, you can see one of them just here. Press that down, and then it will slide out. I'm going to use something a bit more blunt so I don't keep piercing through stuff. Okay, now we can test purely the switch. Also, I've got to remember to put that back in as well. So, do we have anything between here and the top one? We shouldn't have. No, we should have that there now, which we do, but we shouldn't have it here. Press it in, and then we do. So there's nothing wrong with the switch. The switch is fine. Okay, so what I was measuring was through, sorry, when I go on here and press the button, it will disconnect. It's on that one. So I was measuring just, you know, between here and here, the resistances. Yeah. There. Right, it's not that. And there's a load of screws down the bottom here as well. And the idea is the guard here you can put up on a wall, and then you see you can just hang it, you know, on a wall, so that will go against the wall there, and you can just pull it out when you need it. If you have wall space, that is. Okay, right, here we have the gearbox full of cut-ins, but then that's not going to stop it from working. I will have to try and clean that out. I'm not going to do that now because I'm going to get everything real messy. So does this come out here? How am I going to separate this? This should be able to be separated anyway. I'm just going to cut through that sticker. I wonder, does this thing lift off? They sound like angry clips. Like they're going to break on you. There we go. Whoa. Okay, so you do have to take that off. Now are you going to come apart? Yes, you are. Yeah, I'm in at long last. I'm in. First of all, which might be a clue, there's this floating around. Oh, gone again. This doesn't look good. That there is that a brush? Oh no, is it the, I bet that's a brush from the motor. So I bet you, voltage, I bet if we plug the battery in, I bet there is 18 volts going to here. I think the motor has lost this Feels incredibly hard to turn. It's okay that way though. All right, it's 18 volts, yeah? So what would it be? What would it be at the motor? It might be 18 volts at the motor. Should we start at maybe 10 and see if it's turning? So I'm just going to use my bench power supply to put voltage directly into the motor. That way then we don't have to mess around with having to hold down different switches. I'm just going to start at 10 volts, see if there's any twitch from it. There was a twitch. Let's go the other way. There was a twitch there. It's weird, that felt quite powerful, but now it's not doing anything. It's not drawing anything. I'm going to go up, but I think I'm up to 13 volts. I think I could go all the way to 18. I don't think it's going to make any difference at all. It's not drawing anything. I'm at 17 volts now. I'm not going to go any higher. There's nothing there. So it's a problem with I can see a bit come out of it. Right, 1 second. I just seen a little bit here. The motor's gone. Look, there's this thing. Just here, I just seen this thing move around. What is it? Something burnt. I could be wrong because it's so hard to see, but to me the inside kind of looks mangled. It looks like, right, you see that copper thing you can see in the middle? It looks like it's going down in this direction. It doesn't look like it's going down straight. I think the motor's broken. See what I mean? It looks like whatever it is not down straight. So I need to get access into the motor. So what I'm doing is I'm just bending back the tabs. I want to get access to where the brushes and stuff are to see what's going on inside. Clearly something burnt's come out of it, and also half a brush has come out. So I just want to see what's happening on the inside because it's too hard to make out through the holes. There we are. Excellent. Right, that's a little bit bent, but it's fine because look, it's designed to move around anyway. So it's, yeah, look, there. Right, so that is going to go back in okay. Let's see what's happening here. Let's zoom right the way in. Right, so I can see one brush here, but I can't see any here. This is broken. This is broken off. Here you go. Here it is. This is it. Ah, okay, so you've snapped. That's weird. That's strange, because I mean, what's caused that to break off? There we go. Okay. Now, what's this rubbishy stuff here? Is that supposed to be here, or is that something else that's burnt? Oh, hold on. What's happened here? Oh, has the whole thing come apart? Oh, no, it's the motor itself. It's the motor itself, and this here, I think, is burnt plastic, where it's been rubbing, because it's still been working, and this is burnt plastic, where the actual bit of this, you know, that the brush is attached to. Armature or something. Armature. This thing. Can you see it's broken here? Oh well. Okay. I was going to say I wonder if there's a way I could solder that back on, but this here is broken. So the motor itself has gone. Oh well. Not fixable. I'm going to see if you can buy any of these, because maybe they're the same ones that's in loads of different tools. And also it's actually burnt deep down inside. So if you have a look here, look at this white fan. Can you see it's nice and clean this side? But look, it's burnt this side down here. Let's see if I can turn it to get it over this side. There you go, you can see the burn bit coming around now. Here you go. And this is it, broken here. Fair play, it's still connected to the windings, because these are going to be going down to the windings, aren't they? It is still connected to the windings. Thing is though, I'm never going to be able to make that round, and it's not going to be smooth. So these, even if I was to solder this back on and, you know, get this working, I think the brushes will just wear down so quick. Tell you what, let's see if we've got ohms reading between these things, because it looks like there's 3 of them. So maybe the motor has like 3 windings. So let's go between here. Let's move the bush out the way a second. There, right. So what have I got between here and here? Complete short, would that be normal? Yeah, I got a complete short between them. I mean, it'd be really noisy, and it would probably only work for a couple of minutes, and it may go up in flames. But I wonder, could I bodge it back together? But then I suppose you could say, what's the point?
Bodge it, Vince, please bodge it.
Yeah, do it, Vince. We want you to bodge it.
Please, Vince, please bodge it. Okay, calm down everyone, calm down. My public have spoken. If my public want me to bodge it, then of course I will bodge it for you. I mean, 99% of other people would just check on Google and they will see that these motors, because it's written on the side what it is, go for sale from between around £8 and £22. Not sure what the difference is between them all, and a lot of them seem to have different gears at the end. The gear on this is like on good, like really good. I'd have to take it to my dad's shed in order to try to remove that. I wouldn't have anything here that would be able to do that without causing a lot of damage. And I would prefer to buy one that already has the gear on, because then all I've got to do is solder on 2 wires and put in 2 screws. The problem is I'm not going to be able to order that and get it done in this Advent special here. So because the public want me to fix the motor, I'm going to try to fix out a burnt out motor. I'm presuming that will be more fun than soldering 2 wires and doing up 2 screws. So what I have to do is take the motor out with 2 little screws from the gearbox, and then I have to unsolder the leads, nice and easy. Then what I'm doing is I'm mixing up some epoxy, 2-part glue that makes a chemical reaction to go nice and hard. The problem is I'm slightly worried because it says it withstands extreme temperatures, but those temperatures are only from minus 23 degrees to plus 82 degrees Celsius. And I remember, because this motor here reminds me of a 540 motor that I used to have in my Monster Beetle and Hornet and other Tamiya cars. And I remember the motor did used to get very, very hot. And if the can on the outside gets hot, I presume the inside's super hot. So I'm not sure if the epoxy can withstand the temperatures that this motor is going to get up to. But we're going to give it a go anyway. So what I'm doing is pouring epoxy down into it once it's mixed, and then I'm having to kind of hold it steady with pliers and tweezers and stuff to try to get it into the right place. I can't let the plates short against each other. I know it looked like there was direct shorts between them when I was testing on my multimeter, but they're going through windings, which is creating the magnetic field. If I short the plates together, 100% it won't work. So all 3 plates have to be separate from each other. Of course, 2 are intact, so they are already separate. But the 3rd one, which is broken, I need to make sure it doesn't hit the plate on the right or the left of it. It has to be in between. And also it has to be relatively round as well. So while that's going off, we now need to turn our attention to the broken brush and see what we can do with that.
Right, that's still going off there. I'm going to move it carefully to one side so it doesn't all fall apart. I've taken out the 2 little fibre washers that go on top there. It gave me a little bit more room to see what was going on. Have to remember to put them back. Now, I was thinking about how to do the brush thing. And obviously I'll have to make an electrical contact by soldering it on, because this is, I'm hoping, copper. I don't actually know that though. But I'm hoping I'll be able to solder that onto the arm sticking out. But I think it will just, it won't take much to break off completely. So what I'm wondering is, if I was to get a little spring and glue it on, and then it could be supported, so the arm's coming out here, but it could be supported with the spring against the edge of the motor. And it will put a little bit more contact against the motor. So I'm just wondering if a tiny little spring would do the job, but I've got a feeling these are all going to be too big. You know what I mean? If I was to glue that on. I'm going to give it a go, because I can always stretch it if it needs to be longer. I wonder, instead of glue, could I solder it? Would these things solder? I'm not sure. Shall we try? Poor yellow mat's a right mess. Might be a good thing though, it might not be so bright. Right, let's see if we can get solder on here. Yes, we can. In fact, it's nice because there's like a big well. You can fill it right up with solder. Look at that. Now, let's see if the spring, I don't know whether spring solder or not. Let's see if the bottom of the spring will solder. Oh my word, it will. Not really sure what metals do and don't solder. Okay, now let's see if we can get that onto here. So I'm going to arrest that and try to heat it up. And see if I can drop it into place. Probably hot air would work better here. Let's heat up the solder, see if it go all the way around. You can see it travelling, you can see it wicking around. I hope I don't break that brush. Right, it's melted all the way around. Can I drop that in? No, hold on 1 second. I want to crush that more. I want the end of the spring not to be that shape. 1 second. I want it to be more rectangle. Not like that though, it's too much. Well actually, if I can open it up, I wonder could I get that on here? I might be able to. Yeah, that might work, you know, yeah, like that. If I can push it down. Right, let's do that. Right, so heat up again. Right, let it go all the way around, like that. Down, now keep the heat on it. I know you can't see anything. Going to keep it held down till it goes fully. Oops. Oh well, sprung off there anyway. Right, let's have a look at that. Has that gone into it? I think it has. I think that's gone into it. Right, well, hopefully I'll be able to sort of manipulate that into place. Ooh, it's not bad.
Pardon? Sorry, what's that? Oh, thank you very much. Yeah, I'm immensely proud of it. Yeah, correct. It is amazing.
Right, I can feel in the packet now that it's gone sticky. Yeah, it hasn't gone off. I'm going to see if I can take out my tweezers here and here. Now I'm going to clean my tweezers and then I'm going to put them back in dry. Not this one. I think that's done its job. In fact, it all looks like it's holding now anyway. There we go. Now I'm going to put this back in. There. And hopefully now nothing will stick. Now I'm just thinking ahead, it's still drying, but I'm wondering how am I going to join this onto the existing bit. And I found this, I can't remember what it was from. I think it might have been from clipping in one of the faders in the Bang & Olufsen or something. Not too sure. But it was on my desk. In fact, what it was is it was stuck to this, so it probably flew off at some stage and just stuck onto there like a magnet. So I think what I'm going to do is, I think I'm going to solder that on to here, because I can see that this is the original finish here. This is the side that wasn't soldered. This is the broken bit here, because this has a nice finish. It's got a nice edge. So if I was to basically put the point in here, then that will be small enough, I think, to fit onto the other one. And it will just give it a little bit more of a mechanical connection between the two. So I think that's what I'm going to try to do. I just don't want to melt all this lovely bit that I've done. But when I go to join this in the other one, it's going to all melt anyway. So I think I need to do it like that way, and then fill up the whole area with solder. So right now I'm just going to tack it to the spring. Okay, so now you see when I solder that onto the other one, this will give me a little bit more room. Then I think I can just flood the whole thing with solder and it might all kind of melt together, you know? So I need this to go all the way in here. Doesn't look like there's anything that can short up there. This spring might be far too big actually. Just going to have a look up here. Yeah, I have to be careful because I've got all the metal coming down from this contact. Remember, this isn't the contact. This is the contact for here. This is the contact for my one. But that is quite far down. If I can keep it to that plastic there, then I should be okay. It's just if it goes below that, it's going to short. I think that spring's going to be under too much tension, so I'm going to take a little bit of it off. There we go, that might be it. That spring's still way too much. Oh, hold on. So the one that broke was actually off this side, wasn't it? That's half, that's come from here. Because look how big this one is compared to this one. So that was from there. So this might not be big enough to go between both of them. It looks like it might be though. Right, I'm wondering now if I was to solder that to that, is that going to be under too much tension, I wonder? Maybe. Thing is, it's not shorting against anything from what I can see. So I think I'm going to put this in here to put tension on it there. And I think I'm going to try to flood that area with solder. There you go, that's nice and straight there. If I can flood that area with solder, I might be onto a winner. I'm going to use flux to help it flow. Now what might happen is this metal thing that I've put on might just flow, you know, it might just melt completely off and then fall into it, because gravity is not on its side. In fact, you know what? Let's be sensible, that is going to do that. So you're not going to be able to see it flow. I am going to put this horizontally, because I do actually want this to possibly work, believe it or not. So I'm just going to be doing it in here, and hopefully then if it's going to fall into where I want it to solder. Can't see anything because the flux is just smoking up everywhere. There's plenty of solder going in. Must be melting to something. Oh my. Well, you know what? I couldn't have actually hoped that that would have gone any better. If you have a look, I haven't completely filled that metal thing, but remember there was legs coming down this side. Well, the legs look like they're covered. And then we've got a little bridge to the spring. And can you see that's relatively straight? There's a bit of flux on it. And now look, if I get the motor, can you see? So we've got a little bit of give here. Yeah, on the proper one. And we do have a little bit of give there. I can't check though, have we got a short against here? Because we've already got shorts against here, unless I was to hold both of these back. But I think I'm going to do it on my bench power supply first of all. And then it will just do excess current. It's not going to damage anything. Right, well there's a lot of flux around the place. Let's give it a quick clean with IPA. And then I think we're going to put the bench power supply on it and we'll see what it's doing. So I clean it with some isopropyl alcohol and then I pop the back on. Getting the back on is a little bit awkward because it's quite a tight fit, and remember I've already sort of bashed it to get the back out, so the back doesn't want to sit in very nicely, but eventually I do get it in with plenty of whacking. And yeah, now we're ready to test it on the bench power supply. Wow, I think that's the most bashed up motor in the history, but amazingly it seems to be turning both ways. Right, okay, now let's see if you are going to do anything. I've got my bench power supply on 6.34 volts. Oh, it wants to go. Ooh, we have life again. We have life. Should we see if it goes the other way? Yes, it does. Amazing. Right, I'm going to go up to 10 volts and then I think I'm going to pop it in the machine and finish the video. I don't think I'm going to be able to kickstart it though. Oh, now it's quickening up. Oh yeah, it's really going for it now. Probably going to explode, trying to cover it from my face. Do you know what? Maybe, I was about to say maybe it's cleaned up. it's really going for it. Let's just try it the other way. I can see it sparking. Let's get it back in the machine so I can finish the video. I know this is all pointless. I just think it's more interesting than just replacing the motor. But clearly the motor does need replacing. Take this video with a pinch of salt. It's all just a little bit of fun. What I would like to know is though, what is the best glue to use for high temperature applications? Because I know in my heart of hearts that this is just going to fail if I had it on for 3 or 4 minutes, because I think the temperature on the inside will get above 82 degrees Celsius. I had a look, super glue is around 100 degrees Celsius, but yet when you look at Google AI, it's a lot higher than that, but the more you look into it, it's around about 100 degrees Celsius super glue. But there must be glues out there that can withstand higher temperatures. What are they? If you could put that down into the comment section below, because I think that would actually be very useful, not just for me, but for other people as well. And yeah, just to say it again, I know this motor isn't going to last. It's just for an Advent special like this. What do? End the video saying it needs a new motor, or do I try to get the motor working? We all know it needs a new motor, and if I put a new motor in it, I think this thing would be as good as new. Not quite sure why the original motor failed. You tell me. Do you think from manufacture that brush was just ever so slightly damaged or something, or fractured and it got put in and it just broke? Or I can't see, you know, branches and stuff wouldn't have gone up this high into the motor. So I can't see why it's failed. Is it just a manufacturing defect that's caused this one to fail prematurely? So yeah, next time you see this now, it's going to be back together. I haven't put all the screws in because I do have to buy a motor for this. I've had a look on eBay. They're selling for around 60 UK pounds, which seems to be the same sort of price as they are when they're new. And the motors are ranging from 10 to 20-ish pounds. So I think I will get a motor if I can find one with a correct gear at the end. But anyway, it's back together now, and let's see, is it actually going to work when we have all the gears connected to the motor, or will my homemade fix be too weak? Okay, I'm filthy, but this is on now. So, what do you think? I think it's not going to kickstart. Let's see. Oh, that's good news. Come on now. Just want to see if the safety's working. Okay, here we go. Yes! Okay, Vince, don't do any more. I am going to go to bed and I am going to pick this up tomorrow and let's see if we can cut something in the garden. But yes, amazing. So, although the motor is absolutely ruined, it does seem to be powerful enough to actually move the blades here, which is fantastic. Okay, it's the next day. I haven't really got anything to cut, so I'm coming back to this little shrub here. Let's see if I can cut a few little leaves off it. I can hear varying speeds. Well, it certainly works. Well, there we go. So there we have it, the Einhell hedge trimmer. Listen to it go. I really enjoyed that motor fix there, even though it is completely pointless. But what I liked about it is I fully got to see the inside of the motor with the windings and stuff, and I didn't really think much before about how a motor worked, but each of those little commutators, 2 of them was good, 1 of them was bad, they're connected to coils of wire which is doing the magnetic field, and because this one had come loose, then basically it jammed up the brushes and stuff like that. But it's interesting to see how they work. I never really put much thought into it before, but by looking more closely at a motor you get to understand it a bit more. I hope you enjoyed this video. I don't know why I did like it, because it's a product that I can't really use. Heart of hearts, I know that this is going to fail after using it for a few minutes, but I still enjoyed it.
Strange, isn't it? But that's the way it is. So if you enjoyed it, give it a big thumbs up, and I will see you again, hopefully, fingers crossed, tomorrow for another Advent repair. Take care, everyone.